A ball is thrown upward with the initial velocity v0 from the surface of Earth. The motion of the ball is affected by a drag force equal to m gamma v square, where m is the mass of the ball, v is the velocity, instantaneous velocity, and gamma is a constant. The time taken by the ball to rise to its zenith is, 4 different options are given, and it's a question from JEE Main 2019. Look here. Here is given that a ball is projected in the upward direction. So assume that here a ball we are projecting in the upward direction. Okay. Now, you know that when you are throwing a ball in the upward direction, see which are the forces acting on that. See, if the mass of the ball is m, there will be downward gravitation force. Earth is pulling the body in the downward direction. So here mg is the force acting in the downward direction, or because of the gravitation, mg force is acting in the downward direction. Now, when the ball is moving in the upward direction with a velocity v, initially we are projecting with a velocity v0, initial velocity is v0. You know that when you are moving against air, there will be a drag force, fluid friction will be there. Air will be flowing past this. As a result, what happen? Some resistance will be there. In the opposite direction of motion, some force will be acting on that body. That is a very complicated, non-linear, highly non-linear force. The density of the fluid matters, the surface area matters, surface roughness matters. A lot of factors are there. So there will be a force acting on the body, moving body. Any body moving in a fluid will be under the action of a force known as drag force, which is acting in the opposite direction of motion. That means if the body is going in the upward direction, there will be drag force acting in the downward direction. So that drag force, let us take it as Fd, that is given as, Fd is given as m gamma v square. Okay, where v is the velocity. These two conditions are given. So initial velocity is v0, is moving in the upward direction. The drag force is given. Drag force direction is always opposite to that of motion, and gravitational force is there. What is the net force acting in this case? We can say that F net is equal to mg plus m gamma v square. This is the net force. But you have to apply the sign here. Since it is acting in the minus y direction or in the downward direction, we can give a negative sign here. Minus of mg plus m gamma v square. Now we can equate this to F is equal to ma, Newton's second law. F is equal to ma. Now the acceleration part we can easily isolate, because if I am taking m common, we can say that the acceleration or the net acceleration, let us call it as a net. A net is going to be equal to minus of g plus gamma v square. So we got an expression for net acceleration. So here we have to find out the time taken to reach the zenith. That means time taken to reach the maximum height. That is the idea. So here you can see that if the ball is moving from the ground level to a maximum height, at maximum height you know that the velocity is going to be 0. See, when h is equal to h max, okay, we can say that velocity final is going to be 0. So we can say that initial velocity, how much was the initial velocity? Initial velocity was v0, that is given in the problem, v0. So v0 to, it will reach 0 velocity. Velocity final is equal to 0, and that will happen during a time interval of t. If that is the case, we have to find out the time taken to reach the maximum height. Fine, we can do that. With the help of some integration, we can do that. Let us see how to solve that problem. See, first of all, the acceleration. Acceleration is defined as, what is the definition of acceleration? Acceleration is d by dt of velocity, right? From our acceleration expression, a net, how much is a net? Which is equal to minus of g plus gamma v square. Fine. So now we can do one thing. You can just substitute this equation here. We can see that minus of g plus gamma v square is going to be equal to d by dt of v. Fine. We can do one thing. We can do the variable separation. Variable separation is a technique in solving differential equations, or in this kind of situation we can use variable separation. So now you can see that dt I can bring to one side, dt, because there is no other time variables here. So we can say that dt is equal to dv divided by g plus gamma v square. Fine. Let us do integration. So in the next step we are going to integration. Look here. So minus of dt is equal to dv divided by g plus gamma v square. Fine. We are going to integrate. So how to integrate? When you are integrating minus of 0 to t, from 0, starting from 0 to t dt, which is equal to integral v0 to v, because the variable is dv, v0 to v, or v0 to 0, sorry, v0 to 0 we can put, okay, or v final, no, dv divided by g plus gamma v square. Fine. So here left hand side how much will come? When you are integrating it will be t. So when you are applying limit you will get minus t. Minus t is equal to, see how much is this? Here you can do some simple manipulation, mathematical manipulation. dv divided by, I am going to take 1 by gamma common. Okay, if I take 1 by gamma common, you can see that gamma multiplied by, I can write g by gamma, okay, plus v square. There is a reason for this. You will soon understand why we are doing this mathematical manipulation. Look here. Here minus t is going to be equal to, if I take this gamma again outside, 1 by gamma v0 to 0 dv divided by, you can write down g by gamma, you can write down like g by gamma under root whole square, okay, I can write down like that, plus you can write v square, okay. So here this is of the form, this integration is of the form integral dx divided by a square plus x square. What is the answer for this integration? This is 1 by a tan inverse x by a, okay, 1 by a tan inverse x by a is answer, plus maybe constant. Anyway, the constant will not come in our case because it's a definite integral, limit is given, okay. So when you are using this model here, this expression here, we have to do some substitution. Anyway, we know this, this information is very well known in the mathematics, integral calculus. So let us substitute that. So that means minus t is equal to 1 by gamma. So when you are applying the integral, you will get this answer, 1 by a. What is a here? In our case, equivalent to a, we have g by gamma. Root of g by gamma is our a. A square is equal to g by gamma, because you know that g by gamma is only there. Now 1 by a, that is 1 by root of g by gamma, okay. Then tan inverse x by a. What is x? In our case x is v divided by a. What is a? A is again root of g by gamma. This is what you have to solve. And what is the limit? You have to apply the limit here. Limit is from v0 to 0 is our limit, okay. Now here we can do some arrangements again. This is going to be equal to minus t is equal to 1 by gamma. So here this root gamma will go to the numerator. So we can write 1 by gamma root of gamma divided by root of g, okay, tan inverse. Here gamma will go to the numerator, or we can write v multiplied by root of gamma by g. We can substitute again, limit we can give v0 to 0. Let us do this. Here you can say this gamma, we can cancel out this root gamma and gamma, we can cancel out. How much will come? So this is going to give you root gamma here, or you can take inside. That means 1 by root of gamma g will come. So minus t is equal to 1 by root of gamma g tan inverse v root of gamma by g in the limit v0 to 0. Fine. So here we can apply the limit now. So minus t is equal to, see when you are applying limit, root of gamma g and see upper limit you have to apply. So when you are applying upper limit, tan inverse 0 will come. Okay, because velocity is 0 minus tan inverse Now velocity become v0. v0 under root gamma by g. Okay. Now we can see that we can rewrite it as minus of t is going to be equal to 1 by root of gamma g. This tan inverse 0. Tan inverse 0 is 0 because tan 0 is equal to 0. All of you know that. See, tan 0 is equal to 0. So tan inverse 0 should be equal to 0. So this becomes 0. 0, or you can, you don't need to write down. So here minus of tan inverse v0 gamma under root of gamma by g. Fine. Here this negative and negative will get cancelled out. Okay, both sides we have negative. So finally when you are writing down the expression, we can see that t is equal to 1 by root of gamma g. Okay, then tan inverse v0 under root gamma by g is the correct answer here. Let us see any option matches. See, 1 by root of, see anyway this option is there, this is there, this is there, tan inverse, sin inverse. See here, this is the only option I think, tan inverse gamma by under root of v0 into gamma. So this is the correct answer. I hope all of you understood this. This is a very good question from JEE 2019.